Good afternoon, Professor. Today I'm talking about assignment 2. So the first part, the Grass-Fire algorithm, like breadth first search, finds the shortest path step by step based on the fewest steps, but ignores edge costs. So we can see in the part 1, the star-centric method is better for exploring all paths from the source. So we can see in this problem, we start by setting the start node to 0. Then we visit its neighbors D, E, and P, and set their distance to 1. Next, we visit its neighbors of D, E, and P. So these neighbors are B and C. E's neighbors are H and R. P's neighbors is Q. So all of them becomes 2. Then go next, we visit the neighbors of B, C, H, R, and Q. B's neighbors is A, C's neighbors is A, R's neighbors is F, H's neighbors is Q. So all of them's distance becomes 3, but Q has already been visited, so we just skip it. Finally, we visit F's neighbors, its goal node. The goal node's distance becomes 4, meaning it took 4 steps to reach goal. So the path is start E, R, F, goal. The next part, we use Dijkstra's algorithm and find all the shortest path from the start node to the goal node. So we set up the initial table. The start node is set to 0, but we begin there, and all other nodes are assigned to infinity. Infinity, since we don't know their distance yet. So none of the nodes are visited at this stage. Let's go next. Step 2. We begin at the start node. Its neighbors are D, E, and P. D, E, and P, and their cost 3, 9, 1. So we update the cost and path for this node. Then go next. We mark the start node as visited. So next step 3, visit the node with the smallest cost. So the smallest cost is P. P costs 1. The only neighbors of P is Q. So 1 plus 15 is equal to 60. The path is going to be updated, and we mark P as visited. So let's go next. This smallest cost is for D. D just needs to cost 3. So these neighbors are B, E, and C, and then cost 3 equal to 3 plus 1 is equal to 4, and 3 plus 2 equal to 5, 3 plus 8 equal to 11. So we updated the path, and the visited goal marked as D. So let's go next. So now the smallest cost is for B. Cost is equal to 4. But B doesn't lead to any unvisited nodes, so we move on. Next, we visit E. Then its neighbors are H and R. So H is gonna be 13, and R is gonna be 7. And we update the path, and we mark E as visited. Let's go next, continue with the next smallest cost node. So the next smallest cost is R. It's 7. So we visit R's neighbor is F. So the cost to reach F is gonna be 7 plus 2 is equal to 9. and we mark R as visited. So we go to the next. So F's neighbor, F is the smallest node. It's 9 coasts, and F's neighbor is Go. So 9 plus 2 is equal to 11. Now we reach the goal. So we updated the goal and we mark F as visited. So in the final table, we can find the goal path is start to DERF goal. Then the total distance is going to be 11. So in the part 3, the part 3 Graphsphere is simple, fast algorithm based on BFS that finds the shortest path based on the fewest steps, ignoring edge cost. Dijkstra's algorithm is a cost-sensitive, finding the least cost path by considering edge weights. Even if it involves more steps, Graphsphere works best for unformed cost graphs. But Dijkstra's is ideal for graphs with varying edge weights. So, yeah, that's all. Thank you.